Hi class. So I'm going to make a couple of short videos which you can access to hopefully help you with any webassign questions that you will have. We won't have as much in-person class time, so I'm hoping that this will kind of compensate for that. And you can still always send me an email, or for having virtual classes online, ask questions then. I just thought this would help. So for the second webassign from the energy chapter, it's mostly about potential energy and conservation of energy. And I might split this up into a couple of videos, so just kind of look for whichever problem you need help with. The first one I'm not going to say very much at all about, because that's really kind of straightforward. It's just the work or potential energy equations. There's hardly anything to say about that one. Same thing for the second one, where there's a big picture of like a cliff building, I guess. And that one, again, you're just going from one spot to another, saying that, how much did the energy go down or maybe up, I'm not sure. But you can definitely have negatives in that problem, because if you've got a certain amount of energy here, you definitely got less energy here, and some of those answers are repeated. So for my numbers, I see like 183 several times. Okay, now for number 3, I am going to do some work for you, and we're going to go with magenta. So problem number 3 has this object, which is on a string, and it could go all the way down to the bottom. However, it snags on this sort of peg or something that's sticking out, so that it goes in a path kind of like that. So it's hard to do this without a string, but imagine this thing moving, and then snags, and it goes around like that. Letter A says, what is its speed when it reaches the lowest point? That one's not too bad. Definitely have some potential energy up here. That's definitely going to turn into kinetic energy right at the bottom. We're probably going to call that bottom our 0, or our base level. So we definitely can say that all of the potential turns into all kinetic if that's 0. So we can just do mgh, mv squared over 2. Oh my goodness, physics magic happens and the m's go away. Because we do not have a mass of this object. That's okay, we don't need it. And so we can then just solve for the v. And I'm not going to do all the numbers for you, because you're going to have different numbers anyway, but you can definitely do that. Okay. I think I might switch back to the black. I think this might look a little bit better on the screen. Letter B says, what's its speed when it reaches the highest point after the string catches? So they want the speed here. So now, if we start with all potential energy here, we definitely have some potential energy at the top there. However, that's going to turn into, when it does this, it's not going to stop moving completely here. So we definitely have some kinetic at the top, but we also have some potential energy at the top. And I wrote the PE kind of small there, because that's definitely less potential than we've got there. So whatever we lost here is what gets turned into kinetic there. There is more than one way to do this problem, but I think this is just a complete way to describe it, so I'll just happen to do it this way. And we do want to get the speed there. So once again, we're going to do m, g, h, and I'm going to put top. mv squared over 2. And mgh, it's not really the bottom here, but it's kind of like this height here. So what can we do to make our life easy for this one? What can we get rid of? M once again. There's a g there and a g there, but not a g there, so you can't get rid of those. Now for this h, this height right here is really 2 of these radii put together. And so I think we have a number for that. We do. I think you have to actually get that from the picture by subtracting, but you can definitely get that. So I'm going to put in 2r. So we've got all those numbers. You do need to do a little bit of algebra, and you can get the v from there. Maybe we can do one more problem in this group. Let's try and do one more. Any questions? Oh, you can't answer. All right, that was number 3. Excuse me. Number 4 is another good one to do, so we'll kind of talk about that one. So we've got a skier. He's definitely going down a hill. He goes back up a little bit of a hill, and then at this particular point here, he sort of takes off. And does something like that. And they give you an angle here, so I'm just going to write in theta. I think everybody might have the same angle for that one. But we do have some different heights over here. And we want to get the height over here. This is a nice problem because we're going to use some energy stuff. We're also going to use some old physics stuff, some of that projectile motion and kinematics things. So we are indeed going to start with potential energy at the top, and we're going to set that equal to kinetic energy right there. Now you might say, well, what about he's going to go farther down the hill and he's going to go even faster? Yes, but then he's going to go up the hill and lose that. So this fact that he goes down there and back up there makes no difference whatsoever. We're really just interested in these 2 points, this level. It doesn't make a difference. One of the explanations for this is that gravity is a conservative force. So the fact that you go from there to there is what matters. If you go down and then back up, that's kind of like a no net change or difference. So once again, you can definitely do mgh and mv squared over 2, and you can indeed solve for a v. That v there is the same as that v there. Once you get to that v there, you have a speed, you have an angle, and you should get 2 components. You really only need that component, I think, the vertical one. Once you get the vertical component, that is what's going to determine how high you go. So if we want to get a distance, we've got a vertical speed. Now it's a projectile under the influence of gravity. H there. Our final speed at the very top in the vertical direction, big fat 0. Our initial speed is the vertical component that we found. We know our acceleration, and we can find a height, how high the thing ultimately goes to. So not too bad. A little bit of energy, a little bit of kinematic stuff. And I think we'll probably stop there for that one. I'll do the other 3 hints or suggestions in a separate video, so it's not as long and you don't have to scroll through as much, okay? So keep working on your web assignment. Write out all your work. The thought process of doing all this is much more important than just getting the right answer. The right answer is not everything. And you will see that a lot on your tests and on your AP tests too. So keep working on physics. You can do it.